What are derivatives, or what do we mean by differentiation of a function? To answer this question, let's take a simplest function y equal to fx equal to 3. That's the constant function. There is no change in the value of x. Therefore, we can see it clearly that change in fx equal to 0. There is no change in fx. So let's increase the complexity. Let's introduce another function, say y equal to 3x plus 5, or fx equal to 3x plus 5. Definitely, if you change x, value of fx will change. Of course, if I change x, value of fx will change. Now, y equal to 3x plus 5, if you graph it, y equal to 3x plus 5, if you draw a graph of this function, or fx equal to 3x plus 5, then you will get a straight line with slope equal to 3. That's the graph of that function, fx equal to 3x plus 5. But we are not interested in graph, we are interested in change in fx. You see that as x changes from x to x plus h, fx changes from fx to fx plus h. Therefore, change in fx is f of x plus h minus fx. Now, what can we say about f of x plus h? That's equal to 3 times x plus h plus 5. We are replacing x by x plus h. And what about fx? That's given to be 3x plus 5. Okay, we can simplify this expression and we can write it as 3x plus 3h plus 5 minus 3x minus h. Oh, we can cancel 3x, we can cancel 5, and so this is just 3 times h. So if we take the simplest function, let's say simplest one, we could have taken fx equal to 0, or rather let's say constant function, we see that change in fx equal to 0. That's a nice number, right? Change is simply 0. But in this case, it's not that nice. Change in fx is dependent on what is the change in x. So instead of talking about change in fx, let's talk about change in fx divided by change in x. Change in fx is nothing but f of x plus h minus fx. What about change in x? We are changing it from x to x plus h. So that's the change. That's simply equal to h. Now f of x plus h minus fx, we have computed it to be equal to 3h. And h is simply h only, denominator. Let's write change in fx as delta fx. And change in x is delta x. Well, you can cancel we can cancel h out if h is not equal to 0. And you see that change in fx by change in x is simply equal to 3. Well, it turns out that this change in fx by change in x gives you slope of that line. So we got a nice function in this case, let's call it nice function, that change in fx by change in x gives you just 3, the slope of line, or the slope of the function. Does it happen for other function as well? So we have started with fx equal to constant function. We found that change in fx is 0. And then we took a linear function fx equal to 3x plus 5. And we found that change in fx is not constant, that's 3h. But change in fx divided by change in x is a constant, and that's equal to 3, and that's equal to, in fact, in this case, slope of the function fx equal to 3x plus 5, slope of the curve 3x plus 5. It's just a straight line, and slope has turned out to be 3. We increase the complexity. We consider fx equal to 2x square plus 8. And then again determine change in fx by change in x. So change in fx is given by f of x plus h minus fx. We are increasing x by x plus h. Maybe h may be negative as well, might have been decreased as well. Let's say we are increasing x by x plus h, x by x plus h. So change in x is x plus h minus x. Change in fx is f of x plus h minus fx. F of x plus h, we replace x by x plus h. Fx copy as it is, 2x square plus 8 divided by x gets cancelled, so just h. That's equal to, well, we can expand it, so 2x square, a plus b whole thing square is a square plus 2ab, so 2xh, 2xh into 2 is 4xh plus h square plus 8 minus 2x square plus 8 divided by h as it is. Can we cancel something? Yes, 2x square gets cancelled. Oh, minus plus minus, so this is minus 8. 2x square gets cancelled. 8 in 8 gets cancelled. As long as h is not equal to 0, we can take h common and h will also get cancelled. So we cancel out h. So in this case, change in fx by change in x is equal to 4x plus h. Last time we got a simple number, right? Change in fx by change in x. It's simple number. Now we see that change in fx by change in x depend on the value x as well as h. Oh, we have a problem, right? What kind of change are we doing that affects your change in fx by change in x? Can we get this quantity to be independent of h? Of course not. But if we take h nearly 0, so if we take h nearly equal to 0, then change in fx by change in x is nearly equal to 4x. This h will almost vanish. It's almost 0, say 0.00001. If I take, then delta fx by delta x is just 4x. Is there some mathematical way of saying it? We say that limit h tends to 0, limit h tends to 0, f of x plus h minus fx divided by h, that's your change in fx by change in x, is simply equal to 4x. H almost vanishes. Now we have observed that change in fx by change in x gives you actually slope of the line or slope of the curve. So what does it gives is actually slope of the curve at the point x comma y. And we write this as dy by dx or derivative of y equal to fx. And this is nothing but slope of a given function fx, slope of y equal to fx if you graph it at x comma y. Okay, we tend to get the slope of y equal to fx at the point x comma y just by finding derivative. That are, what are derivatives? This is the change in fx by change in x when change in x is nearly equal to 0 or in the limiting case. Once again, dy by dx or derivative of y equal to fx is given by limit h tends to 0, f of x plus h minus fx by h, and it turns out to be giving us slope of y equal to fx at x comma y. Now, does it happen that it always gives you the slope dy by dx? Okay, now let us look at this graph of some function. I don't know which function, but maybe we are getting this kind of graph. You see some kind of spike here. We tend to move smoothly, but suddenly there is some jerk or some disturbance or some suddenness in change in slope. What about if we move that side as well? The similar things are true. What about in this case, if we have graph of a function given to be this way, then you see that there is no change in direction, right? No change in direction. But out of a sudden there is change in direction. Okay, one more point. Can I draw a tangent at this point? Of course you can. I can draw tangent, of course, this point. At this point, yes. But what about this point? At that point, I won't be able to draw the tangent, because if I move from the left hand side, I'll be drawing tangent this way. Whereas we move from the right hand side, I'll be drawing tangent that way. You don't get a unique tangent to this curve. The same is true in this case as well. There is a spike here. So no tangent, spike, so no tangent at the spike, right? But can we draw tangent or at other point? Yes. So we can determine slope of the tangent at this point, at this point, at this point. In other words, we can find derivative of a function that is having graph is this is given in the picture. But we won't be able to find the derivative whenever we have spike, or we won't be able to draw a tangent whenever we have a spike in the graph. The same is true here. We can find derivatives. In fact, it is a linear, right? It is just going to be a straight line. So derivative will be constant. We can find derivative as long as we are, or we can draw tangent at those points. In fact, tangent will simply superimpose with that curve as well. We can draw tangent at those points, but not at this spike point. Now you see that in this case, you don't have a spike. No spike. Or we have a smooth curve throughout. So when is it that we can talk about the derivatives? If we have graph of a function to be smooth. So if graph of a function is smooth, in other words, no spike exists in the graph of the function, then we can talk about the derivative of the function, and the derivative of the function at the point gives a slope of tangent at that point. So derivatives basically gives a slope of the tangent to the curve at that point.